Good day, everybody. We have a factoring problem today, a completely factoring problem that ended up with a result I didn't expect, so I thought I'd share it with you. But we're obviously talking about integer values here, and so we need our integer n to be greater than or equal to 5, clearly. Now, there's something called the gamma function that makes this thing continuous, but I'm not going to be dealing with that. We'll just be dealing with a discrete version of the factorial. But 0 factorial is defined, and there's a nice reason for that. We won't get into that. In fact, there's been a ton of videos on why this is equal to 1, but it's very consistent with the probability formulas. And also combinatorically, there's one way to select no objects, I guess, if you want to interpret it that way. But in any event, we have to have n can't be like 4 because that would be minus 1 factorial, which has no meaning discretely, I don't think. Okay, so let's get busy here. Now, to me, this is the so-called deepest part right here. We can consider n minus 5 factorial the greatest common factor simply because of the definition of the factorial function. N minus 2 factorial can be rewritten like this, okay? And so that means that n minus 5 factorial is common to the first term and it's common to the second term. So it's the biggest thing common to both terms, all right? And so towards that, we just carry on right here and factor out n minus 5 factorial, okay? And of course, only 24 is left right here. Then the n minus 2 times n minus 3 times n minus 4 is left. And I didn't bore you with the multiplication of these linear factors, but this is the polynomial you end up with: n cubed minus 9n squared plus 26n minus 24. Now we catch a break here, which makes the result sort of interesting in my opinion. The 24s do cancel and an n will factor out of this, and so we'll end up with n times n minus 5 factorial times a nice little polynomial that's irreducible. Okay, what's left here after you take away an n would be n squared minus 9n plus 26. And it did say to completely factor, and you can verify very quickly that this is irreducible over this quadratic here is irreducible over the integers or anything, I guess. It has a negative discriminant. The discriminant, I believe, is we'll just call it d. The discriminant is equal to 81 minus 4 times 26, which we can see is less than 0, right? So this actually has complex solutions, but it's irreducible over the integers or over the real numbers, I guess. In any event, this is the complete factorization. It's as low as you can get. It is a product of stuff, and we are done. So thanks for viewing.